Team, let's talk about RAG, Retrieval-Augmented Generation. It's the way that we provide context to LLMs at the right time to get the most relevant responses grounded on information that actually matters. I'm Arya. I'm a solution engineer at Salesforce. I've been implementing the product for the last 5 years for companies large and small. I focus on our AI and customer data platform products as Agentforce and Data 360. I'm here to make your wildest CRM dreams come true. So let's get started. Retrieval-Augmented Generation, or essentially the way that we give more relevant context to our LLMs to provide better responses for the right people at the right time. And Salesforce does this in a few different ways. And to make this real for you guys, I had a client that would take documents, files, PDFs, whatever it might be, and put them directly into Box, and had a goal in mind to process those documents for agentic retrieval across the enterprise. And that is exactly what Salesforce Data 360 does. It gives you a place to store terabytes and terabytes of information across multiple file formats, PDFs, DocX, PowerPoint, MP3, MP4, so on and so forth, to process for agentic retrieval. And Salesforce provides an intense amount of options to process that information, including parsing, pre-processing, different multilingual embedding models for chunking, section-aware passage extraction. The list goes on. The idea behind it all is the same. It's that this information is siloed. Let's bring it into one place and let's process it for agent actions and agent retrieval across the enterprise for my teams in sales, in service, in marketing, in operations, the executive team, whatever it might be. And so when we come into Salesforce and we think about the files that maybe we're uploading to a place for unstructured data, SharePoint, Box, Google Drive, whatever it might be, I can certainly come in to these files and go ahead and maybe use, for example, Box AI and get a summary of this file, but it's a bit clunky to go into every single file and try to pull out the information that I care about. So why not use Agentforce to execute this across the enterprise of documents? And so for the Salesforce account here, I might ask, for example, what account-related files have information about malicious code? Now, if I had 50 files, 500, it would be a superhuman task to go through all of them, especially if I'm new to this account, and try to determine which ones have the insight that I care about that's going to move things across the finish line. Well, Agentforce is grounded on all of this, and our retrievers have filters available in them that allow us to hone in on just the documents that we care about, which are attached to this account. And that's why I can find related information that specifically defines malicious code. And we've listed the file name, the file ID here as well. That also means that if I go to Omega and I have a completely different document and I ask the same question, for example, what account related files have information on malicious code, we're not going to return results. We're going to get the agent coming back saying, hey, by the way, I looked at the files related to this account, and I couldn't find information that mentions malicious code. We're not hallucinating. We're not going through documents that aren't attached to this account. We're providing relevant information about what is related to this organization. In addition, if I, for example, wanted to go across the enterprise, and I don't care if I'm just looking at Salesforce, I don't care if I'm just looking at Omega, and I want to return results across all documents, I absolutely can. And that is where I can come over to the home screen, for example, and I don't have any account up here. I can jump in and I can say, hey, what dealership document contract information can you find? And Agentforce is, because of the way that our retrievers work, the way that our actions work, I can point Agentforce to a retriever that is grounded on the entire, that is going to search the entire database of chunk documents without filters if I wanted. And so we can search all of our docs and return information. But jumping back to Omega, I just want to make sure that we do say, by the way, no document specifically mentioned that. So I have the relevancy for my agent's grounding available and here for my team to answer questions in the right way at the right time based off of the information that is actually available. If I search across the enterprise, I'll also get information around any perhaps dealership documents across the entire enterprise, which means I can then take action on this if I wanted to, for example, use previous proposal, quote, project plan information to draft new project plans. I can search across the entire enterprise if I want to, or I can hone in on only the information that's relevant to this organization. And that's what we're going to go into today. We're going to set up a unstructured data connection. I'm going to go through how we create our search indexes and our retrievers and the options we have for intelligent RAG. And we'll go through retrieval filtration and enabling this for the teams that need it the most. So let's get started. Team, why is intelligent RAG so important? I want to illustrate this with an example. Here I am in ChatGPT, and if I upload a file, for example, a product photo, and I drop this in and ask ChatGPT, how about how many wheels are in this product? You and I both know if we look at this product, there's a wheel in the front, there's a swivel caster here, and there's likely a third one on the side here, making for 3 wheels. Well, LLMs can't see this image. The way that they process it is through OCR, optical character recognition, which means they convert or analyze this image and they glean information from it based on a textual representation. And that's why ChatGPT is saying, hey, there's 2 wheels. There's a large mane and a small caster. Well, this is incorrect, and we know so. Going into Gemini and asking the same question, let me upload the same product image. If I ask the same question, how many wheels are in this product? Gemini is also going to do the same thing. It's going to create a textual representation of this image and then analyze the text or the chunk that comes back. And it's going to say, hey, we maybe have 3 wheels, which is great, but only 1 large drive wheel and 2 front support casters. It's hallucinating. It said there's 2 small swivel casters at the front. That is incorrect. There's only 1. And this represents unintelligent RAG, or Retrieval-Augmented Generation. This is one of the largest problems that many of my customers face, is the LLMs themselves may or may not pull the right insight from these images, and without any control over how the LLM actually processes what it is being fed, we find ourselves in fairly dicey situations, especially if we want to enable this across the enterprise. And that's where Salesforce is going to shine, is what we're going to talk about today. Now, in the Salesforce platform, I have a ton of options for intelligent RAG, for the way that we process this information. We have search index types, parsing options, pre-processing options, image parsing, and then even embedding and chunking options that help you get the most out of the information that you're making available for unstructured data processing. Which means if I come in to my intelligent context builder here and I actually want to preview the chunks that are generated, I absolutely can. I can preview the textual representation of this information, and I can ask the same question. I can say, how many wheels are present? And because Salesforce gives me the ability to use something like LLM-based pre-processing and image processing, 2 methodologies for getting a better chunk, we are going to see that the Power Pusher is equipped with 3 wheels, 2 2 large durable wheels on either side of the main body and a smaller caster wheel. This is accurate. This is grounded. This is not hallucinating product specifications that aren't there. And it means that if we expand this across the enterprise, we can be more confident that the information we're giving our people at the time they need it is actually what they need, grounded in the information for my business. So let's go ahead and get this started. The first part of the equation is connecting to a source of unstructured information. Now, for me in today's demonstration, that is Box. But this could also be Google Drive, this could be SharePoint, this could be an Amazon S3 bucket, any source of unstructured information. For the purposes of demonstration, I'm using Box simply because they had a free trial. I know they connect well with Salesforce, and we have a publicly facing Data 360 integration guide for this specific connector, in addition to hundreds of other connectors as well. All I had to do was head over to the integration guide page and follow the instructions here to the T and set up my connection. In a nutshell, this involves configuring and creating a Box application and authenticating it against Salesforce. That means coming into my Box developer console, creating that Salesforce connection in my platform apps, heading over to Salesforce and to the other connectors section of the setup menu, and then configuring with my client ID and client secret the credentials required for Box.com. And that was about it. The only other thing I had to do to get started was head over to Data Lake objects here in Data Cloud. Now keep in mind, you will need to have the access permissions required for Data Cloud. That's likely going to be Data Cloud Architect and Data Cloud Admin as permission sets assigned to your user. Once in this tab, all I had to do is I hit the new button. I wanted to create a new Data Lake object from external files. That's creating from an unstructured Data Lake object. Hitting the next button here and choosing Box to ingest information. So once that is all set up, I will put the free trial link as well as the integration guide link in the description of the video. Feel free to continue with creating a data lake object for that unstructured data. It is worth noting, if you do want a window into the Box system from Salesforce, you can absolutely download the Box Intelligent Content Management app from the App Exchange. What that'll do is quite literally give you a panel of glass that allows you to hurl documents through to have them land directly in Box. As you can see here, the folder taxonomy will start with the object name and then the account name for this account. But if it was cases, we'd be talking about the case number here as well. That taxonomy and that folder and file name kind of structure can be edited from the Box app itself. You can head to the app launcher in the top left and type in Box to be able to adjust those settings. There's something I want to call out here. On the files that I've added, you might notice that there is a tag, and that tag represents the ID of the parent record here, the Salesforce account record. That is very important for us because when you bring that unstructured data back into Salesforce, it's going to be important for us to have a reference to the Salesforce record that it's related to. So that can be the file folder path, that can be the taxonomy, however a relationship can be made. Typically we'll use a unique identifier. It's important to have that metadata or that description of the file with a relationship to the Salesforce ID or the Salesforce record available for us to filter on. Here in the Box application in Salesforce, all I've done is hit the More Options, 3 dots icon, More Actions I'm hovering down to, and adding or editing tags. And that's where I've added the Salesforce ID as a tag. Because I know that tags are information that does come back from the connector. As I jump over into the data Lake Object tab in Data 360, I'm going to go ahead and hit New. I'm going to hit From External Files on the left-hand side. I'll hit Next, and I'll choose Box as my connection. From there, I can filter what I want to come across. If I need to, I'm going to go ahead and hit Next, and then I can give a name to the DLO, the data lake object, and the corresponding DMO. Now, I've already done this, and I will actually open up the box files DLO. The mappings will happen automatically, and we'll see the metadata here as well. This and these columns, these fields, are information that's come back from the connector that's going to describe the file. And the one that I want to call out for the box connector in particular is something called labels. Labels are super important because that's the tag. That's the tag that I dropped on this file itself. 001, KA, 3, 4 zeros here, so on and so forth. And this holds the relationship that that file has to this record. Which means if I come over to Data Explorer, for example, and I select the DLO representing box files, what we are going to find is that under the label column, we should see, I'll go ahead and edit my columns here, and I will add labels in here. Let's take out data source and description and e-tag, and let's add labels and hit done. On the right-hand side, we're going to see a couple of those file IDs come back immediately for us. And this is what we can use subsequently in our retrievers to filter the results that are returned. Folks, now that we have a connection of information into Data 360, it's time to process that information for intelligent retrieval by agents. And we're going to do that processing through the creation of a search index. Now, as I come into Data 360, there is a tab here to open up search indexes. If you don't see it, you can hit the More option here and click Search Index. Now, I will go ahead and create a new search index by hitting the New button up at the top right, and I'm going to go with the Advanced Setup option. I'll hit Next, and I'm going to be able to choose two options here for search type: vector search or hybrid search. Now, I'll keep it as vector search just to start, but hybrid search is a combination of vector and keyword search, can provide more accurate results. My data model object here is the box.com files data model object that we created when we first made that connection, or that DLO as well. So I'll go ahead and hit Next, and I have some parsing and pre-processing options. These are ways that we can extract information from files that maybe have images in them, for example, for more accurate or more relevant, more detailed chunks that our agents can use for more intelligent RAG. And I can try all of these options out by heading over, once again in Data 360, to the Process Content tab. So I'm going to come over here and head to the Process Content tab, and on the left-hand side, I'll click on Intelligent Context, and I can create a new configuration to perhaps even trial some of this out. Now, I have an example configuration here already, but what you're going to notice is that I have the ability to compare the chunks created with the source material, and I can also edit the configuration on the left-hand side. So if I did want to perhaps try and upload a file and select a parsing, pre-processing, or chunking strategy and see the chunks potentially that would be created and ask Agentforce to test the relevance of these chunks, I can do that as well before heading over to my search index and running this across the entire database of unstructured information that I've pulled in. When I'm ready to go, I can move forward with my parsing and my pre-processing options, as well as my chunking strategies. For PDFs, for example, we have section aware, and we also have passage extraction as an option. In addition, you can prepend fields to each chunk and enable image processing as well. You can choose max tokens and overlapping token amounts here as well. The embedding strategy for vectorization, the Salesforce embedding v2 model will actually change the max amount of tokens that's allowed here. It'll bring it up to about 8,000. So you have a few options for determining how best to chunk out your documents, your files, whether or not we do want to enable image processing for images that might be in those documents, flowcharts, diagrams, whatever it might be, and to enrich those chunks by prepending fields to them. If this is a case information or case description or resolution and things like that, you can prepend additional case metadata, file metadata to those chunks themselves so that anytime they're retrieved, the agent knows additional information about it. For example, the title, the subject, so on and so forth. Moving forward, you can also use fields for filtering to return and identify relevant fields from the related data model object to include in the index. And one of those fields that I've included is the labels field. This lets me dynamically fill it at runtime when I need to retrieve this information. I get to use this to dynamically pass in the account ID when I want to retrieve files only, perhaps only related to the Salesforce account or the Omega account, so on and so forth. When you're all set, you can hit review and build and save this search index, and it will work its magic. When it is all set, you can head over to the search index itself and take a look at the processing history to determine when it started, ended, the records that were processed, skipped, the size, the chunks created, chunks deleted, and the job status as well. With that search index created, we will have the processed textual representation of that unstructured data in Data 360 for us to then retrieve. And that's the last step, really, is creating that retriever, creating a way for us to call that information and return, based on what the user is asking, a relevant answer, or the chunks that represent the documents that answer that question. And so that's what we're going to do here. We're going to head over to Einstein Studio. It's just another tab in Data 360, and we're going to go ahead and create a retriever. I'm going to head over to the Retrievers tab on the left, and then I'm going to hit New and create a new retriever. Now, I have a retriever built here that I want to walk through for you all. And in the Retriever Builder, we're going to choose Data Cloud to retrieve data from a Data Cloud search index, the default data space, the DMO for the box.conf files that we ingested, and the search index that we just created in the last step as well. On the left-hand side, we are going to define our retriever filters. Now, at default, I can return all documents, which means if I wanted to search across the enterprise, I could have a retriever that does that. I can have a second retriever that filters documents to return and does so when the label of that chunk is equal to perhaps a certain value. And I have checked the box on the left-hand side that says this is dynamic, which means I can populate this at runtime. This is how I'm able to, at runtime, pass in the account ID and say, hey, only give me chunks that are textual representations of the files related to the account that I care about, because the label holds that account ID in this demonstration, and I will pass in that value at runtime, and I'll show you how to do that as well. This is a low or no code retriever option with Salesforce. There is a more advanced option that we provide with the platform that I will talk through as well. As I move forward, I can not only define my retriever filters and pass in values at runtime, But I can also configure my retriever results. Now, this is all a feature of our low or no code retrievers. These are point and click options for defining how you want to return results from the search index that we created. How do we return or receive relevant chunks that answer the question that our users or our customers or our dealers or third parties have asked? And as I choose what information to return, I have a couple of options. I can choose up to 50 results to return, and I can choose fields to return as well. In addition, I have a couple of citation settings that I can choose here if I want to add standard or custom citations. But in addition to the chunked information, I might want to return, how about the label as well? And I can choose, the direct attribute of the label. I can choose to return from the retriever the chunk that is there as well. Or maybe the title of the file. Our chunk will also be something that's incredibly important for us to return. That's going to be a related field there. And so that is the actual textual representation of the document. So important for us to return that information as well. Now, what if I wanted to return more than 50 results? What if, for example, dynamic filter at runtime is not good enough? I don't just need to pass in the account ID. I also need to make sure that if the industry is in manufacturing, we only return relevant documents for the manufacturing part of a customer's business. Additional filters, complex filters, those are also available, but those are more pro code or using SQL, using Apex to create custom retrievers that can do the things that we're looking for outside of the limits of these low or no code declarative options. In Salesforce, what these retrievers do is they query those search indexes. And so we can, with SQL, do the same thing here. You have all of the data, all the chunked information available in the org. And so running a query to grab the key information, the key metadata from those files is absolutely possible, including the information from that chunk, the chunked information. And so if I think about using SQL, well, I can absolutely get around the 50 chunk return limit or the 50 record return limit in those declarative tools. I can also add additional clauses. I can add a where clause here, right? Like where ID equals a certain value, where the title of the account is something else, where the source record ID is something else, where the folder is something else. So on and so forth. I can add other complex logic that I need to further filter or define the results that are returned from querying that index. Because we are using low or no code retrievers today, point and click, I'm going to move forward just to review my configurations, making sure that my filter, which I care about, is in there, that will be dynamically set at runtime. The last step here really is just to give an agent access to that retriever. Give it a place to collapse the context needed to answer my team's question. That means a place to include or search for all of that amazing unstructured data that I've brought into the system, maybe even further external data that I've brought into Data 360, maybe even core Salesforce data that I want to hydrate my context window for more intelligent responses. And the way that we do that in Salesforce is with a prompt template. It's a runtime window where I can pass in things like the user's input or their question and the retriever that we just created, that box.com files retriever. I can do so by opening up a new flex type prompt template, including the inputs that I added an account here in the user input, which is a free text. That is context I want to bring in. And then going ahead and inserting resources, choosing the search option, and then selecting from the retriever list the retriever that we created. In addition, I could add maybe a web retriever if we want to go out to the web and do some web searching. Absolutely possible there as well. But again, a place and a window to, at runtime, collapse multiple sources of information as context for an agent to make and determine a response and an answer. This retriever, if I click into it on the left-hand side, we'll see some details, including at the bottom, a pre-filter. And that is where I can make sure that the chunks returned have a label that matches my account ID. And that's how we make sure that everything returned is relevant only for the organization that we care about. So how's this going to work in practice? Well, if we jump into Agent Builder and we take a look at our agent, we know that there is a topic already that I've configured here called File Insights and Summaries. And in that topic's action is a reference to that prompt template. And when the agent goes and runs this action, that's when it's going to hydrate its contacts with the information that it's pulled from that retriever. So if I ask, for example, what account-related file information can you find for Omega, we know that we're talking about Omega Inc., and we should go and run the prompt template that grabs information only relating to files attached to Omega. And for Omega, it is a CRM CPQ selection RFP, and so I should only get information that corresponds to that document. So coming back into Agent Builder, what we're going to see is that action was launched. Retrieve box.com file information for the account, and what we should see is file information return only for that file as well. And that's how that works in practice. We went through a box unstructured data connection. We chose how to process that information. We gave an agent access to retrieving that information, and we went ahead and ran that action inside of the builder. The next step is activating this on multiple channels, taking additional actions on it, or even, certainly possible, is creating multiple retrievers. This may work for our sales and service team, but maybe our executive team and maybe our ops team need different retrievers that don't have filters associated with it. And you can create those as well, and you can add those as context into prompt templates for our agents to call as well. Once that information has been processed, it is yours to do with as you please. But in no ways are you limited to only using low or no code retrievers, filtered retrievers, or query all type retrievers. You can use a combination of what you need for the people who need it in the ways that they need to get their work done as fast as possible. RAG gives your team a way to activate the playbook of your business across the entire enterprise.